Hi friends, previous video we have discussed about the cylinder block construction in detail and also liners. Now this video I am going to explain about the crankshaft. Crankshaft is also the most vital part in the engine. So what is the job of crankshaft? How the crankshaft is made and what material is used in making the crankshaft and what process is used in making the crankshaft. In addition to the crankshaft, I am going to explain about some other associated parts with the crankshaft. That is the vibration damper, flywheel and crankshaft counterweights and also the bearings. As I have given the notes in the previous video, I have given 2-3 pages notes at the end of the video, compiling some important points. Hope it will be useful to you. So let us move ahead. So what is the crankshaft? A crankshaft is a device fitted in the engine to convert the reciprocating motion, that is up and down motion of the piston, into the rotary motion. Whatever the energy generated inside the combustion chamber makes the piston to reciprocate. Okay. Whereas to run the automobile, to run the vehicle, we need to convert this into rotary motion. How the reciprocating motion has to be converted into rotary motion. Okay. How the crankshaft does it. Let us look into that one. You can see this small animation. A man is pedaling the bicycle. Okay, observe it. How his legs are moving. His knees, you can observe his knees or toes. The legs are moving up and down. That is a linear motion or reciprocating motion. Whereas these wheels are rotating in a circular motion. So how this linear motion is converted into rotary motion? This is like this. This is the crank. This is a common shaft. Okay, and that side one crank. Our feet is here. So which is pressing this and again which is pressing this. This goes down, that comes up. Again that goes down, this comes up. So like this, the up and down movement of the legs are being converted into rotary motion of the cycle wheels. Same way, we can watch what is happening inside the engine. The piston is moving up and down. Okay, it's moving up and down. It's moving up and down. But we want exactly a rotary motion to run the vehicle. Means to run the clutch, to run the gearbox, to run the differentials, everything, everywhere we need the rotary motion. See, this is again crank. This is called crankshaft. The two pins. One is the connecting rod journal pin. The other one is the crankshaft main pin. Two pins have different axes. This is how a reciprocating motion is converted into rotary motion. This is how the crank mechanism. Exactly speaking, how this idea has come of converting the linear motion into rotary motion, we do not know. It is a really great idea. So how it has come in the history, in the past, I do not know. But somehow I am going to explain a simple mission which Romans used almost 17 centuries ago, means 3rd century AD. You observe this, means you can see the crankshaft design, how old it is. You can see the crankshaft thought process idea may be much behind this actually. How this mechanism works. Let's have a look on this actually. This is the water wheel made with wood. This is the wheel. These are the blades. and this is supported through a shaft. At one end shaft is having gear, and the gear is again meshed with other gear, and this bottom gear is having again a common shaft. This common shaft is having both ends crank pins like the cycle pedal is having here, and like this crankshaft is having here. So see, this is the axis of the main pin, this is the axis of the crank pin. Here one crank pin, here one crank pin. Now when the water flows through the gravity, this falls on the blades and this wheel is rotated. Along with the wheel shaft is rotated, the gear is rotated. These are all rotary motion. Again this gear is rotated. Whereas this crank, which is moving circumferential to the axis of the shaft, will push and pull. When it comes here, okay, it is different distance from here to here. When it comes here, again distance is different. It pulls and pushes this connecting rod. When this connecting rod is moving like this in a linear way, whatever the saw is attached to this connecting rod also moves here, cutting the wooden block. Same way this side. So this side also. This is connecting rod, this is the saw frame, this is the saw. Same mechanism was used by the Romans even to cut the marble blocks also. This is the crank mechanism used by the Romans 17 centuries ago. But here one difference between the internal combustion engine and this mechanism you have to see here, the rotary motion is converted into linear motion. Rotary motion is converted into linear motion. Again the mechanism is crank. So this is the concept used by the engine manufacturer to convert the linear motion into rotary motion. A 4-cylinder inline engine crankshaft looks like this. This is called front side of the crankshaft. This is rear side of the crankshaft. Okay. This is called shaft. This is called flange. And this, whatever in the same common axis, 1, 2, 3, 4, 5 are called main journals, which sits in the block. And whatever is offset, these journals are called connecting journals. 4 connecting rods, 4 piston and 4 connecting rod journals. 1, 2, 3, 4. Again, the axis of these 4 connecting journals are different. This is 4-cylinder and 4 journals, 6-cylinder, 6 journals. Again, it is a V-type engine. Again, there will be 1 journal for 2 connecting rods that we are going to see in the future. This is the piston and connecting rod assembly. This portion is connected to the crankshaft journals here. This is how it is arranged. Crankshaft supported with main caps, fitted to the bottom, the crankcase of the cylinder block. The piston and connecting rod goes inside the cylinder, and this is called big end of the connecting rod. This is small end of the connecting rod. Big end of the connecting rod is attached to the crank journals. You see this drawing. How to determine the stroke of the piston. What is meant by stroke of the piston? The stroke of the piston is the distance traveled by the piston from one end to other end. Okay. How this stroke is determined? The stroke is determined with the design of the crankshaft journals and the axis of the crankshaft journals. See, this is the center axis of the crankshaft journal. When the piston is moving up and down, the shaft rotates like this. The dotted line indicates the circular path of the axis of the crank journal. The diameter is nothing but the stroke length of the piston. If this journal is little bit far away, the stroke length is more. If the journal is little bit inside, the diameter of the circular path is less, the stroke is less. So this is the geometry of the stroke of the piston. This is how it moves inside. You can see the animation. When the crankshaft is moving continuously, okay, at 1500 rpm, 1000 rpm, 2000 rpm, petrol engines up to 6000 rpm. Crankshaft journals needs continuous lubrication, whether it is a main journal or the crank pin. It needs a lubrication. How the lubrication is passed? There are drillings inside connecting pin to pin like this. So there is a gallery in the block here. You can see the holes here. This is a hole. Through this gallery, from the oil pump, the oil comes to this gallery from this hole, and it is entered into the hole of the main journal, lubricating this bearing as well as passing some oil to the. This is the main journal. Lubricating this journal and passing some oil to the crank pin also through this internal hole. This is the internal hole. This is the cut section of the crank shaft. See, the line diagram looks like this. These holes are made for lubrication oil circulation. As I told you, this is the very critical component and vital component in the engine. It is subjected for various loads, vibrations, torsional forces, because there will be continuous vibration on the piston, connecting rods, and vibration is passed to the crankshaft. Okay. So an appropriate material has to be used to withstand all odd things. Considering these all toughest conditions like continuous vibrations, impulse loads, torsional loads, etc., etc., crankshaft is made with special medium carbon steel of around 0.3% of carbon. In addition to the medium carbon steel, certain other important metals also mixed with this alloy. Metals like magnesium, chromium, nickel, molybdenum, silica, and vanadium. So all these are mixed in the proportionate as per the metallurgist design, and this is made through forging process. Blocks are made with casting process, whereas crankshaft is made with medium carbon steel mixing some other metals proportionately made through the forging process. Forging, finishing, heat treatment, etc., etc. is done. Okay. Now let us look. This is the front side of the crankshaft. In the front side of the crankshaft, this vibration damper is fitted here. What is the job of the vibration damper? When the engine is running, as I told you, because of the continuous heating on the piston crown, and a lot of vibrations are transmitted to the crankshaft. Okay. And when it is rotating, lot of torsional vibrations takes place. Torsional forces takes place. To protect the crankshaft from breakage or crack, there should be some element to absorb the torsional vibrations. That particular item is the vibration damper. This vibration damper absorbs all the torsional vibrations and impulse forces in this, because this is made with special fluid and specialized rubber, calibrated, dynamically balanced and sealed. This is very critical part of the crankshaft. Any external heating, any denting, any leakage of the fluid leads to failure or breakage of the crankshaft. This is front side of the crankshaft, and when you come to the rear side of the crankshaft, this flywheel is fitted here to this flange. What is the job of this flywheel? The job of this flywheel is to store the energy. When the energy comes during the power stroke to the impulse, it has to store. But whatever the energy is stored, it has to give back when the piston starts moving upwards. And this transmission of the power has to be very, very smooth. So this is the energy storage device, and also it transmits the power very, very smoothly to the next devices like gearbox, clutch and all actually. So flywheel also is very important component. So in addition to that, a gear ring is fixed on the flywheel to mesh with the self-starter pinion, which is used for cranking the engine for initial firing. This is the flywheel. In a compression ignition engine, combustion pressure will be 200 bar approximately. Imagine the amount of pressure and load on the crankshaft when 200 bar pressure acts on 100 mm dia piston. This 200 bar pressure at the 4 inches dia, that's 100 mm piston, generates nearly 16,000 kgs of pressure in each crank journal. In each crank journal, approximately 16,000 kilos of pressure is generated, that too with impact pressure. Okay, and these forces are always impulsive. To withstand all these impulsive forces, there should be some component which can assist the crankshaft to absorb all these torsional impulsive forces and to safeguard the crankshaft from the cracking or breakage. So these two are such type of assisting compounds. And one more thing we have to discuss here, these are called crank webs. These are called crank webs or counterweights also. It is treated as counterweight also. This is why these counterweights are here. Why not a crankshaft can be made plain without these counterweights? What is the job of this counterweight? There is a serious reason in providing the counterweights. The shaft is rotating. It generates a lot of centrifugal forces. It generates a lot of centrifugal forces. Okay, these centrifugal forces tends the crankshaft to bend or even break. Okay, to absorb all these centrifugal forces, these crank webs are provided. In the larger capacity crankshaft, separate bolt-on crank webs are provided, and these crank webs are dynamically balanced along with the crankshaft. In a compression ignition engine, that is diesel engine, the compression pressure will be normally at 200 bar. If you imagine a 4 inches piston, 4 inches size piston, that is 100 mm size piston, when 200 bar pressure is created during the combustion, during the power stroke, each piston there will be a impulsive load of 16,000 kgs. And you can imagine if the piston is larger than this, 6 inches, 8 inches, 10 inches like this, how many tons of weight will carry the connecting rod and the crankshafts. Okay, crankshaft is designed in such a way to withstand all these pressures, impulsive forces, centrifugal forces, and to transmit the power very smoothly. And this is supported by the vibration damper, flywheel, and crank webs, counterweights. Now let us look at this. This is the crankshaft journal. It's a connecting journal. Okay, main journal. You can see this portion. This portion looks like that. Small dip is there, but with a circular radius you can see. If you expand this, it looks like this. This is the bearing seating area. There is a small undercut, and this is a kind of circular. path. This is called fillet radius. Fillet radius has to be essentially maintained in the crankshaft, because when the crankshaft is made, okay, if you leave the sharp edges here, because of the concentration of the stresses here, because of the concentration of stresses and the impulsive forces, crack starts here. Crack is developed here and the crankshaft will break. So to absorb that impulsive forces and also to distribute the stresses, the stresses are concentrated here, whereas you have to distribute the stress and you have to increase the fatigue handling capacity. Okay, you have to increase the fatigue capacity. So you are increasing the surface area here. So from sharp edge to you are making it slight curvature and you are giving a small dip cut here, small undercut here. This is a big engineering design. This amount of the undercut and the radius to be maintained depends upon the size of the crankshaft, capacity of the engine, which will be designed by the engine manufacturer. Now let us see. This is the shaft, 6-cylinder inline engine shaft. You can see the main journal 7, that is 1, 2, 3, 4, 5, 6, 7 and connecting journal 6. So these are the caps used to mount the crankshaft to the block. These are the bearings. Half bearing is seated in the cap and half bearing is seated in the block. This is lower, this is up. This is the bearing placed in the cap. This is the bearing which will be placed in the block. What is the job of these bearings? Any bearing, simple, is to minimize the friction between the moving parts. But here, why these are special bearings? These are not ball bearings, these are not roller bearings, and these are not thrust bearings. These are white metal half bearings. Why the bearings are designed like this? These are designed like this because the crank journals or connecting rod beget is always subjected for impulsive forces. The piston fires, piston gives a hammering act on the connecting rod as well as the crank pin. So ball bearings etc. will not withstand and the possibility of the breakage will be there. The bearing provided here should give proper amount of cushioning plus lubrication, okay, all these things and all. This is the path for the oil flow, right? And the present bearings are called tri-metal bearing, made with the combination of different metals, okay, having 3 to 4 layers of the bearing, present generation bearings, which you can see here. This is called tri-metal bearing. The thickest one is the back support. This is called steel back, made of steel. It should have the required tension to stick on to the bearing housing, cap or bearing housing always, okay. It should have the grip there. So that's why, and it should also give the strength to the bearing. This is why steel back. The middle layer is copper alloy. So this is the middle layer made with copper alloy. There is specific purpose choosing the copper alloy, because this should be able to withstand the shocks provided in the internal combustion during the power strokes, and again it should be able to withstand for high fatigue stresses, okay. This will be approximately 0.2, depending on the bearing size, it will be approximately 0.2 to 0.5 mm thickness. The next top layer is the overlay. This is the very critical part, okay. This is very critical. It should give excellent cushioning to the crank journals and should be able to absorb the shocks and smooth spreading of the lubricating oil. All these characters this bearing metal should have. So all these characters, whatever I mentioned, the fatigue resistance and impact resistance for impact loading and equal distribution of the lubrication oil, shock absorption capacities, all these qualities should possess by this bearing material. And one more important thing we have to discuss about here, you see this crankshaft main journals bearings, this bearing looks a little bit different. This is with some kind of collar. Okay, this is called thrust bearing. Why this thrust bearing is designed? When the crankshaft is rotating, it tends to move to and fro a little bit because it is rotating freely on the journals. When it tends to flow to and fro, wherever it is touching to the block, the block gets damaged. Okay, and even for to and fro movement of the crankshaft also there should be cushioning and lubrication. This particular thrust bearing gives both sides cushioning when the crankshaft floats or moves to and fro. This is the job of the thrust bearing. So friends, this is about the crankshaft, and I'm here with providing some notes also along with this video. Please go through. If you have any specific questions also you can mail to me. Thank you. These are the notes. Please go through. Friends, hope the contents of this video is useful to you. If you have any questions or queries or suggestions, please email to me or WhatsApp to me. Thank you for watching this video.